Hi, I'm Yu Li. For this set of videos, I will talk about how to apply the valuation principle to calculate the time value of money in the future. These lectures will have 3 videos. The first video will talk about compounding and discounting. If you want to know the future value of investment today after some periods, then we use the compounding process to calculate the future value. If you want to know the present value of a cash flow in the future, then we use this discounting process to calculate the present value of cash flow in the future. In the second video, I will talk about perpetuity and annuity. Perpetuity will give you equal payment frequently forever. Annuity will give you equal payment frequently for some periods. In the third video, I will talk about annuity due and constant growth perpetuity. Annuity due is very similar to annuity, but it moves all the cash flows one period ahead. Constant growth perpetuity is very similar to perpetuity, but the payment will grow at constant rate. For this video, I will focus on compounding and discounting. In Lecture 2, we talk about the time value of money one period ahead. Suppose you have $100 in hand and you want to save it as deposit. The bank gives you 5% in interest. 1 year after, you will have $100 multiplied by 0.05, that is $5. So in total, you will have $100 plus interest $5, that is $105. Now here is a more challenging question. We want to know how much money will be in your account after 2 years. Again, we draw the timeline of cash flow. Today, you save $100 in the bank account, and after 1 year, this money will grow to be $105. Now, I want to encourage you to put this $105 in your bank account for another year. So the original $100 will grow to be $105 1 year ahead, and that is 2 years after. However, we have the additional $5 as interest earned on year 1. So this $5 of interest will grow to be 5 multiplied by 1.05, that is $5.25 2 years ahead. So here, you need to notice the interest is compounded. Your interest in year 1 will grow the new interest in year 2. So if we want to know the future value of investment $100 today, 2 years after, we need to use the interest rate of year 1 to calculate the total interest of year 2. Alternatively, you can write this $105 grows at 1.05. So it will be $110.25. For this course, we use the exponential expression. If you multiply 1.05 at 2 times, it will be 1.05 to the power of 2. So for $100 today, the future value will be $100 multiplied by 1.05 to the power of 2. That is $110.25 2 years after. Okay, now I want to ask a more challenging question. If you don't withdraw money from your bank account during 5 years, how much money will you have in your account 5 years after? We just repeat the calculation of compounding. In year 0, you put $100 in your bank account. 1 year after, you get $105. Now you use all the money in your bank account to wait for another year. So 2 years after, it will grow to be $110.25. Like a tree, the money in your bank account will grow to be larger and larger and larger. So 5 years after, you will have $127.63. Of course, we don't want to write so many equations in our homework or exam, so we use the exponential expression. If you have 1.05 multiplied by 5 times, it can be written as 1.05 to the power of 5. So for $100 today, after 5 years, it will grow to be $100 multiplied by 1.05 to the power of 5. That is $127.63. Okay, so now we know the compounding calculation of bank account. If we know the present value of investment, we know the interest rate as the market price for time value of money, and we know how much periods you need to wait, then we can use this equation to calculate the future value of your investment. Your future value of investment will be the present value multiplied by 1 plus interest rate to the power of n. Okay, now I want to ask an interesting question. Suppose your employer is Zoom. Zoom provides a bonus plan for you. The bonus plan will be $800,000 5 years later. Now you want to know what is the present value of this bonus plan. 5 years later, you will have the future value as $800,000. Now you want to ask how much present value is the bonus plan. Assume the interest rate is 5% per year. You will have $800,000 5 years later as the future value. Now we can write the previous equation. We are expected to find the present value of the bonus plan. Then if multiplied with 1.05 to the power of 5, it should be $800,000. Well, $626,000 multiplied by this number will be exactly $800,000. So we say the present value of this bonus plan is $626,000. You can write this $800,000 over 1.05 to the power of 5. Then it will be $626,000, the same number calculated here. Okay, so this reversed calculation process is the discounting process. If you know the future value of a cash flow, and you know how much periods you will need to wait to get this future value of investment, then you just use the future value over 1 plus r to the power of m to calculate the present value of this cash flow. Alternatively, you can write this formula as the present value equals future value multiplied by 1 over 1 plus r to the power of n. We call this 1 over 1 plus r to the power of n as the discount factor. It is the market price for $1 n years after. Okay, now I want to give a brief summary for this video. In this video, I talk about the compounding process. You can use the compounding equation to calculate the future value of investment today after certain periods. I also introduced the discounting equation. You can use this discounting equation to calculate the present value of a cash flow in the future. Now, as the employee of Zoom, I hope you can calculate the present value of your bonus plan. Thanks.